Hey guys, this is Coach Lowe, and we are going to talk about areas of polygons today. This is Contextual Geometry, Chapter 10, Section 3. Look in your notebook and make sure that you have 10.1, 10.2. If you don't, skip a couple of pages or go back and watch those two videos and then come back and do 10.3. We will have a notebook check this week, and you cannot have any loose papers for credit in that notebook. They have to be in your composition notebook. So there will be a check on Wednesday of 10.1 through 10.4. So make sure you're ready for that. All right. So areas of polygons. We have several theorems. First of all, let's have some definitions going on here. Polygonal region. A polygonal region. That means a polygon and its interior. So we know what a polygon is. Closed figure, edges or segments. They can't cross, they only meet at endpoints, all that good stuff. We talked about that in 10.1. So when you see the words polygonal region, it's talking about the polygon and its interior. All right, postulate 10.1. It's called the area postulate, and it says for any polygon in a unique unit of measure, so like centimeters, meters, inches, like they may say a unit, that's fine. There is a number A, which would be area, stand for area, right? There's a number A called the measure of the area of the polygon. So for any polygon, and then they'll give us a unit of measure, there is a unique area for each polygonal region. All right, we've looked at that. Postulate 10.2 says congruent polygons have equal measures. So if I draw a polygon, let's say I put it on dot paper, and then I translate it, rotate it, flip it, whatever you want to do to it, but I keep its shape. It has the same area. The translation, rotation, reflection, whatever we do, the transformation happens, but the polygons don't change in area. They still have the same area. Postulate 10.3 is the area addition postulate, and it says we can make a composite figure, which a composite figure means you take a rectangle and a triangle or two different shapes and put them together. So if they give me a composite figure made up of more than one polygon, then we can split it into different shapes, and we can find the area of each of those shapes and then add them together and have the area of the entire figure. So the area addition postulate says the area of a given polygon equals the sum of the areas of the non-overlapping polygons that form the given polygon. All right, so that means this rectangle, the area of that one, plus the area of this triangle, add them together, you got the area of this little arrow-looking house thing. All right, let's keep going. Okay, let's look at the area of these guys. Now we're going to use that second postulate. So we have, or third postulate, sorry, actually the second one too. Postulate 10.1 says we have this figure, we can find the area. All right, so great, we know that. Postulate 10.2 says congruent polygons have equal areas. Okay, we don't need that one yet. Postulate 10.3 says, okay, this can be split up into some shapes. So check this out. There's a rectangle, triangle, triangle, square. In fact, there are different ways we could do this. We could split these into little squares, couldn't we? But we know this is a 1, 2, 3. I'm counting the spaces. A 3 by 2 rectangle, which makes its area 6. This one's area is 1. What about these two guys? Notice that these triangles are half of a square, which makes these half if a square is 1. So put those together and we have 1. So 6 plus 1 plus 1 is 8. 8 units squared. Don't put the square on the number, put the square on the U. Okay, if they told us that each side between dots was meters, this would be 8 meters squared. If they told us inches, it would be 8 inches squared. So they didn't give us units, so we'll just put a U for units and square it. All right, let's check out this guy. Go ahead and draw in what you see. It may be different than what I'm looking at, but you could go ahead and draw in what you see. I see a rectangle And I see another rectangle. And then I see 4 triangles. And those triangles are each a half. And so we have 4 triangles, which makes 2 units, right? We put these 2 together and these 2 together, that makes 2. I see a rectangle that's a 2 by 1, or you can also do this and just count the boxes. There's 2 there, there's 2 here. So on the squares, I have 4 squares. So that makes 4. All right, check out this rectangle. It is a 2 by 1, 2, 3, 4. A 2 by 4, 2 times 4 is 8. You could also count the squares. If you wanted to make squares out of all of these, you could do that. 1, 2, 3, 4, 5, 6, 7, 8. Several ways to do this. So one rectangle, it was a 2 by 4, which makes 8. Now we can add all these together. 8 and 2 is 10 plus 4 is 14. 14 units squared. All right, this one is so weird, isn't it? Kind of crazy, but I think we can do this. All right, so go ahead and mark off what you see. So several different ways to do this. I see a 2 by 1 rectangle here and then 2 triangles, top and bottom. I see another 2 by 1 rectangle. So I could have taken this whole thing as a 2 by 2 square. So let me draw that in. So there's a square that's 2 by 2. So that's 4. All right, we've got that one taken care of. Do you see some triangles here? So 2 triangles, that makes 1 because they're each half. All right, what else do you see? So if I go here, I see a square and a square. Now these are interesting squares because they're not this direction. All 4 corners aren't dots. They're coming across a diagonal. So what do I do with those guys? Go ahead and pause your video and see if you can figure out this and this guy right here. All right, so now that you're back, I'm going to show you kind of a cool thing on this one. If you kind of focus on this little rectangle right here, which I know we're only going to take part of it, there's one rectangle, that's a half. And there's another one that's a half. And if you think about this one's a half, and this one's a half. So in each of these squares, there are 4 rectangles, which makes this 2 and this 2. All right, do you see that? I drew the rectangle here with the 4 dots and rectangle here with the 4 dots. And I got 1 out of that one, drew the rectangle here, and I got 1 out of that one. So that's 2 for those. All right, and then this guy, we could draw the square or the rectangle here and here. And so I'm getting half out of those as well. So I have 1 here, 2, 3, 4, 5. So 5 purple ones, 5 triangles. Not 5 triangles. Sorry. I have 5 units because we said there were 4 triangles here, 4 triangles here, 2 there, which makes 10 triangles or 5 units there. All right, so we'll add 5 there. So that gives me 10 total. So 4 in the box, half here, and then lots of halves here, right? We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 halves, which gave us 5. All right, good job. All right, last one. This one's on grid paper, so it'll be a little bit different, but still fun. All right, So area of a triangle we know is 1/2 base times height. All right, so the height of the triangle has to go from an angle to the opposite base, and it has to be perpendicular to it. So like from this angle here, well, that's not going to be very nice because we're going through squares. From this angle here, still not very nice, but look from this angle. Bam, got it. We can measure that. It's a horizontal line. Horizontal or vertical lines from the angle to the opposite side are awesome sauce. So 1, 2, 3 is my height. Let me get back to the green. All right, now the base, maybe you're like, well, we could use any of the sides. Actually, you can't. The base will be the side that the height, the altitude hits. So my altitude hits this side, so now that is my base. And it is, if you start here and you want to count lines, then don't count the first one. So 1, 2, 3, it's 4 units long. You can also count spaces. So area equals 1/2 times 4 times 3. So area equals half of 4 is 2 times 3 is 6. So area is 6 square units or 6 units squared. All right, guys, we'll talk a little bit more about this tomorrow. Remember, make sure that you have 10-1, 10-2, 10-3 in your composition notebook. No flyaways, all right? These notes are not to be turned in. They're to stay in your notebook. And then 10-4 we will add, and then we'll have a little notebook check. All right, this is Coach Lowe, and I'm out.